Hello, good day everyone. I am Marian Joy Estanalon, and today we will discuss about the amide organic compound family.
Before we start our discussion, let's have the learning objective first. So at the end of this lesson, the students are able to define and explain the organic compound family of amide. Second is to identify the properties of amide. And third, construct a structural formula of the organic compound.
So, what are amides? Amides are derived from carboxylic acid, which contains the COOH functional group, and in an amide, the OH part is replaced by an H2 group, so amide contains the CONH2 functional group. So, as what you've seen in the picture, that is the general formula for amide, where R is any group of atoms. So, there are several uses of amides, and it is generally used in pharmaceutical industry to produce painkillers and anesthetic. And several drugs are also amides such as penicillin, LCD, and paracetamol. Amides are also used for ore processing to form resilient structural materials such as nylon and Kevlar, used in construction of dam foundations and tunnels. And another thing, that the methylformamide, which I haven't include in my PowerPoint presentation, the dimethylformamide is also a form of amide, or commonly abbreviated as DMF. It is an important organic solvent, and this odorless liquid is miscible with water and is common solvent used for chemical reactions. So, as what I have mentioned a while ago, sa uses of amides, we can already say that amides are important because of its several uses. And imagine if there's no amide, there is a possibility nga that we can't produce those things if it's the absence of amides. So, with that, we can say nga amides are very important. And additionally, the amide functional group is extremely important for biological molecule because amide amides make up the backbone of proteins. And compounds containing amides have a wide range of biological activity in making medical drug. Piperine, which is responsible for the pungent flavor of black pepper, and anandamide, which provides some of the pleasurable sensations gained from eating chocolates. No, so personally, I love chocolates, and every time I eat chocolates, kana grabe jud ako ma-feel nga sensation ana nga wow, grabe jud kalami. And that reaction, that kind of feeling, ang responsible ana is ang amides. And yes, we are done with the discussion of the uses and importance of amides. Now let's proceed to the properties of amides. The amides has two properties, namely the physical and chemical properties. In terms of the physical property, formamide is a liquid while all other amides are colorless, crystalline at room temperature. The lower aliphatic amide are quite soluble in water. The solubility decreases with the increase in size of alkyl groups. The melting and boiling points of amides are higher than expected. And for chemical property, Amides are least reactive of all the acid derivatives toward nucleophilic acyl substitution reactions. Amides are much less basic than amines. Amides behave both as weak bases as well as weak acids. Amides can be hydrolyzed by boiling with water, acids, or alkalis. So, in providing the IUPAC name of amide, it is categorized into three: the primary, secondary, and tertiary. And for the discussion, let's hear it from Mr. Shakil Provitso.
Now let's proceed to the next part of our discussion. And in this part, we're going to tackle the nomenclature which providing the IUPAC name. So, simple amides are named as derivatives of carboxylic acid. The IC ending of the common name or the OIC ending of the International Union of Pure and Applied Chemistry or IUPAC name of the carboxylic acid is replaced with the suffix amide. For example, formic acid. So, as you can see, formic acid, it's end with the IC acid. Therefore, you need to remove the IC acid and replace it with the suffix amide to form a formamide. So, the naming of amide in IUPAC are categorized into three: the primary, secondary, and tertiary. So, primary amides are named by changing the name of the acid by dropping the IC ending or the OIC ending. The carbonyl is given the number location 1. It is necessary to include the location number in the name because it is assumed that the functional group will be on the end of the parent chain. For example, the amide has 2 carbon atoms and is thus derived from acetic acid. The OH of the acetic acid is replaced by NH2 group. The IC from acetic or OIC from the ethanoic is dropped and amide is added to give acetamide. Another example is that this one, this amide is derived from benzoic acid. So as you can see, the benzoic acid, it's end with OIC acid. Therefore, you need to remove the OIC acid and replace it with the suffix amide to form or to name it benzamide. Now let's proceed to the secondary amides. So in secondary amides, they name by using an uppercase N to designate that the alkyl groups is on the nitrogen atom. Alkyl groups attached to the nitrogen are named as substituents. The letter N is used to indicate that they are attached to the nitrogen. So for the example, this one, as you can see, the methylpropanamide is attached to the nitrogen. So as you can see in this part, in this amide, that they are connected or attached to the nitrogen. Now let's move on to the tertiary amide. So the tertiary amide and secondary amide is quite similar but differ on the number of nitrogen to be added. Like in secondary amide, you need to add 1 nitrogen. But in tertiary amide, you need to add 2 nitrogen. For example, this one. The methylpropanamide is attached to 2 nitrogen.
And for the last part of our discussion in nomenclature, we have the drawing of the structural formula. So in drawing the structural formula, we have the expanded structural formula, the condensed structural formula, and lastly, the line angle structural formula. For the expanded structural formula, it shows all the carbon and hydrogen atoms and the bonds attaching them. Thus, structural formulas identify specific isomers by showing the order of attachment of the various atoms. So, for example, the acetamide. Acetamide has a chemical formula CH3CONH2. So, as what you see in the picture or the formula, structural formula, the atoms are distributed, no? So, kung asa sila na bond, that's it. For the condensed structural formula, the chemical formula show the hydrogen atoms or other atoms or groups right next to the carbon atoms to which they are attached. No? So as what you've seen in the picture, ako dyan na siyang gidraw. And yeah, kanang gisirkulan dira, mao na siya ang condensed structural formula. Mao na siya ang nagpakita og condensed structural formula. Alright? And lastly, we have the line angle formulas. Now, it's simply a carbon atom at the corners and end lines. Each carbon atom is understood to be attached to enough hydrogen atoms to give each carbon atom 4 bonds. So, as what you've seen in the picture, kanang hexagon din ha? Is that hexagon? Yes, mao na siya ang designate as the carbon and hydrogen atoms. And with that structure, it is understandable that the the hydrogen atoms is bonded to the carbon. Alright, that's all for our discussion about the amide organic compound family. So, I hope you've learned something. Thank you and God bless.